Good evening, my dear students. So today in this video I will discuss the remaining portion of the first chapter of class 10, that is chemical reaction and equation. In the first video I have discussed what is chemical reaction and what are the different types of chemical reaction with explanation of all the types of chemical reaction. And then I have discussed what is chemical equation, what is scalable equation and what is balanced chemical equation. Now in this video I will discuss the remaining portion, that is how to balance a chemical equation and some chemical reactions, that is what is exothermic reaction, what is endothermic reaction and what is corrosion and rancidity. These things I will discuss in this video. So those who have not watched the first video, you first watch the first video from the link given in the description, because if you do not watch the first video you may not understand this video properly. Okay, so in this video I will discuss how to balance a chemical equation and what is exothermic reaction, what is endothermic reaction, what is corrosion and rancidity. So first start with how to balance a chemical equation. Suppose if I write a chemical equation where hydrogen reacts with nitrogen and it produces ammonia. So this is a chemical equation for the chemical reaction where hydrogen reacts with nitrogen and produces ammonia. Now it is asked to balance this chemical equation. Okay, so here two questions arises, that is it necessary to balance a chemical equation, and if it is necessary, then why it is necessary? So the first answer is yes, it is necessary to balance a chemical equation. You know what? Whenever we write a chemical equation, this chemical equation is generally called skeletal equation. Why? Because in this chemical equation, what happens is, see, we said that hydrogen when reacts with nitrogen, it produces ammonia. So simply we write the chemical formula of hydrogen and the chemical formula of nitrogen and the chemical formula of ammonia. And this type of equations are called skeletal equation, where only the chemical formula of the reactant and the chemical formula of the product is mentioned. No physical state is mentioned in this type of chemical equation. So it is necessary, it becomes necessary to balance a chemical equation. Now why it is necessary? It is necessary because after writing a chemical equation, you will observe that sometimes some atoms disappeared or sometimes some atoms gains its number. Suppose in this chemical equation, whatever you see here in reactant side, the number of hydrogen is 2, but after reacting in the product side, the number of hydrogen increased to 3. Is it possible in practical? Of course not. And nitrogen, number of nitrogen atom is 2 here in the reactant side, but in the product side the number of nitrogen is reduced to 1. So is it possible practically? Of course not. That is why it is necessary to balance a chemical equation. Why it is necessary? Step back to your class 9 where you got one definition. So not definition, law of conservation of mass. It says that mass can neither be created nor destroyed in a chemical reaction. That means it is not possible to destroy mass or it is not possible to create mass during a chemical reaction. But here if you observe, you will find that number of hydrogen increased. That means the mass of hydrogen is increased. This is not possible as per our law of conservation of mass, and the number of nitrogen is reduced from 2 to 1. That means mass disappeared. This is not possible according to our law of conservation of mass. So to follow, so that our equation should follow the law of conservation of mass, we need to balance a chemical equation. Okay, so we will balance the chemical equation so that the number of atoms in the reactant side and the number of atoms in the product side will be equal. if the number of atoms in the reactant side is equal to the number of atoms in the product side, then obviously the mass of the reactant and the mass of the product will also equal. So that is why it is necessary to balance the chemical equation. Okay, let's start this how to balance this equation. So before going to start balancing this equation, let us have a look at some basic concepts of mathematical calculation, which is going to use to balance all types of chemical equation. If you understand this, it will be easy for you to balance all types of chemical equation. This is not so hard, okay, but it's important. And if you do not understand the small calculation, then it will be difficult for you. This is A. So if I ask you that how many A is here, simply on saying this, you will say that the number of A is 1. But actually a small mathematical calculation is there. What? This is actually the number of A or anything. If I write A, or in place of A, if we write B, C, D, X, Y, Z, anything, the number of A or anything is actually depends upon the number present in this position, that is in front of A or in front of anything, and the position, this position called suffix position. That means the number present in the coefficient position and the number present in the suffix position depends upon the number of A is depends upon. Actually the number of A or anything, B, C, D, X, Y, Z, anything, it depends upon the number present in the coefficient position and the number present in the suffix position. So when I see how do you say that the number of A is 1? Actually the calculation is like this. In coefficient position, that is in front of A, no number is mentioned, that means 1. And in suffix position, no number is mentioned, that means 1. So 1 into 1, 1 ones are 1, that means the number of A is 1. So if I write 2 in front of A, that is in the coefficient position, so 2 ones are, it will stand like this, 2 ones are 2, number of A will be 2. If I write 3 in the suffix position of A, then the number will increase, 2 3s are 6. By this way we will calculate whenever we will go to balance a chemical equation, any types of chemical equation, this type of calculation is needed. Suppose another case, if AB as a whole, if it is inside a first bracket, and if I put a 2 common to this A and B in the suffix position, okay, so here the number of A is 1 into 2, that means number of A is 2, number of B is also 2. If I write 2 inside this bracket and in the coefficient position, in the suffix position, then the number of A will be 2 2s are, number of A will be 2 2s are 4, but the number of B will be still 2 1s are 2. Okay, so again another case you may find, AB and a common coefficient for both A and B. Here the number of A is 2 1s are 2. No number is mentioned in the coefficient in the suffix position. That means no number is mentioned means 1. So 2 into 1 2. For B the calculation is also same. 2 this coefficient is common for both A and B. So 2 into 1, that means 2B. But if I write 3 in the coefficient position of B, then the number of A, you try to do yourself, copy. The number of A will be 2 ones are 2, because in the coefficient position of A, no number is mentioned, that means 1, so 2 ones are 2, that is the number of A will be 2, but the number of B is 2 threes are 2 into 3, 2 threes are 6, because B has coefficient 2 and in its suffix position it has 3, so the number of B is 6 in this case. So this basic calculation is going to use to balance all kind of chemical equation. Let us start this equation. We will balance this equation by using this type of small calculation. This is very easy. Okay, remember this. Before going to balance a chemical equation, any types of chemical equation, some important things that you have to keep in mind, that you can't alter the chemical formula. You can't alter the chemical formula of the reactant and the product involved in the chemical reaction. That means you can't alter the chemical formula of the element or compound involved in the reaction. You can't alter, you can't change the chemical formula of any element or compound involved in a chemical reaction. These things you have to keep in mind. Also, one more thing, you can't use the suffix position. You can't use the suffix position. The only position that you can use to balance a chemical equation, the only place is provided for you is the coefficient position. This position, only you can use this position to balance your chemical equation. You can't write anything here. That means in suffix position, you can't write anything. Only you can use the coefficient position. Okay? So let us try to balance this chemical equation by using the coefficient position. Only you can use the coefficient position. Remember that this is very, very important. Only you can use the coefficient position. So in this equation, the number of hydrogen is 2 in the reactant side, but the number of hydrogen is 3 in the product side. Here the calculation is, see, here the number of hydrogen is 2. That means in the coefficient position, no number is mentioned. That means 1 into, in the suffix position we have 2. So 2 ones are 2. Number of hydrogen is 2. And in the product side, number of hydrogen is 3. How it is 3? In the coefficient position, it has 1, and the suffix position it has 3. So 3 ones are 3. Alright? So how can I equal this? How can I equal the number of hydrogen in both the sides? Simply, if I put 3 in place of 1 and if I put 2 in place of this, what happens you see, 3 2s are 6, 3 2s are 6. The number become equal. So put a 3 in the coefficient position of hydrogen and put a 2 in the coefficient position. Just change the coefficient of the reactant. The coefficient of the reactant side. You do use the coefficient of the reactant atom as the suffix of the reactant atom as the coefficient of the product atom, and the suffix of the product atom used as the coefficient of the reactant atom, and vice versa. Alternatively, you can use to balance this equation. Actually, you know all these things. Now the number of hydrogen become equal. 2 3 are 6, 2 3 are 6. Now come to the next one. There is nitrogen. Here the number of nitrogen is 2. Here also the number of nitrogen is 2. This is 2 by this way. 1 into 2, 2. And this here it is 2 by this way. 2 into 1. That is 2. Right? 2 into 2 into 1. 2. Number of nitrogen is 2. And now one more thing that we can do to write the physical state. To write the physical state. Hydrogen is always, you will find the gaseous state. Nitrogen also you will find in the gaseous state. So in bracket you write G. Ammonia that will produce will be also in the gaseous state. So whenever you balance the chemical equation, try to write the physical state of the reactant and the product. In all types of skeletal equation do not mention the physical state. So that is why whenever we balance the chemical equation, we will try to write the physical state of the reactant and the product. Okay. So let us have a look at few more example. Iron, when Fe reacts with water, H2O, it will produce Fe3O4 plus H2. By pausing this video, you try to balance this equation by yourself. And if you fail, then watch. So start from the first one. Sometimes you will find that some teacher will start from the highest value from the highest number of atoms, the number which has highest value from this one. But you can start to balance anywhere. From I usually start from the first one. Here the first one is Fe. So first start to balance the number of Fe in both the side of the equation. Here the number of Fe is 1. 1 into 1. 1 into 1. That means number of Fe is 1. Here the number of Fe is 1 into 3. That is 3. So I can use the coefficient position. So if I put 3 in place of 1, the number become 3 ones are 3. The number of Fe is become 3. Now the number of Fe is equal in both the side of the reactor of the equation. Now coming to the next one. After Fe comes the next one, that is hydrogen. Number of hydrogen is 2. Here the number of hydrogen is also 2. That means equal. No need to change yet. Now coming to the next one, that is oxygen. Number of oxygen is 1 here, but the number of oxygen is 3. 1 into 1, 1. 1 into 3, 3. So if I use the suffix of 3 as the coefficient of suffix of 3 as the coefficient of the reactant atom. So if I put 3, the number will be equal. 3, 3. Now again count the number of atom from the first one. If any kind of change you find, then balance it again. So number of Fe is 3 here, the number of Fe is 3. It is balanced. The number of hydrogen is 2 3s are 6. It changed. here the number of hydrogen is still 2. So to balance this, here the number of hydrogen is 3 into 2, that means 6. So use the coefficient of the reactant atom as the here the coefficient is same. So you just put the coefficient, suffix is same. So you just simply use the coefficient in simulation. Same. 3 into 2, 6. By this way, number of hydrogen become equal. Now again count whether any change occurred. Number of Fe is 3. Number of hydrogen, 2 these are 6. 2 these are 6. Number of oxygen 3. Number of oxygen 3. That means the chemical equation is balanced. Now write the physical state of the reactant and the product. So Fe, generally Fe you will find in solid state, that means S, and Fe reacts with water. Water at room temperature you find the liquid state, but you can't write L here because Fe do not react with water in the liquid, in its liquid form. Okay, Fe reacts with steam. That means when water in a gaseous state, iron reacts with water and produces this. And this is also solid, and hydrogen is gas at room temperature. That means G. So the equation is balanced now. So you try all the chemical equation given in your textbook, and if you find any sort of difficulties, you mention it in the comment box. Okay. Now the next one is how to balance the chemical equation is complete. I hope you understand. If you have any problem, you can contact. Okay. So now the next one is, what is exothermic reaction? Exothermic reaction. Exothermic reactions are the chemical reactions in which heat is produced along with the product. For example, if you burn coal, that is carbon, in presence of oxygen, it will produce carbon dioxide, and along with this carbon dioxide, it also produces heat. So the chemical reaction in which the reactant reacts together and produce heat along with the product. This type of chemical reactions are called exothermic reaction. So you write the definition: the chemical reactions which produces heat along with the product. This type of reactions are called exothermic reaction. As an example, you can write this, and also you can write C6H12O6 plus O2. That means when glucose reacts with oxygen, it produces carbon dioxide, water, and energy. Energy, that means heat. This is also an exothermic reaction. Okay. Respiration reaction. Now, why respiration reaction? Sometimes you will find the questions like this. So why respiration reactions are called exothermic reaction? Because in respiration reaction, oxygen that we inhale when we breathe reacts with glucose that usually present in your cell, reacts with cellular glucose and produces carbon dioxide, water, and energy. The energy is used for all kinds of activities, or all kinds of biochemical or physical activity of our body. So as in this process, the heat is heat or energy is produced. So respiration reaction are called exothermic reaction. So I hope you understand what is exothermic reaction. Now coming to the next one. What is endothermic reaction? Endothermic reaction. Endothermic reaction is actually the opposite of exothermic reaction. In exothermic reaction, heat is produced along with the product, but in endothermic reaction, heat is absorbed to occur the chemical reaction. Heat is absorbed. For example, CaCO3, calcium carbonate. If we give heat to calcium carbonate, that is, if we provide heat, it will break down to form calcium oxide and carbon dioxide. That means calcium carbonate absorbs heat to produce calcium oxide and oxygen. If you keep this calcium carbonate at room temperature without giving any heat, then no chemical reaction will take place. Okay, so this type of chemical, so the type of chemical reaction which absorbs heat to conduct to proceed this reaction, this type of reactions are called endothermic reaction. Okay, so write the definition of endothermic reaction. So your definition of endothermic reaction is like this: the chemical reaction which absorbs heat to form the product. This type of reactions are called endothermic reaction. Apart from this reaction, you can also write some other reaction. AgBr, light. If you apply light energy will convert it into heat energy. Ultimately, the reaction, the reactant will absorb heat from the light and will break down into silver and Br. This reaction is used in black and white photography. So this type of reactions are called endothermic reaction. Now the next one is, what is corrosion? Corrosion is actually a natural phenomena. All pure form of metal always try to form some stable product, some stable compound, and to form this stable compound, the pure metal reacts with oxygen, water, and forms something, and by this way the pure metal get corroded, and the process is called corrosion. For example, iron. When you keep iron made articles exposed to the atmosphere, if you put iron exposed to the atmosphere, it will react with oxygen present in the atmosphere, also with moisture, that is water present in the atmosphere, and it will form FeOH thrice, and by this way the iron made article get corroded, and this process is called corrosion. In case of copper reacts with oxygen and will form copper oxide, and by this way pure copper get corroded, forming copper oxide, right? And iron is corroded by this way. So corrosion is a natural phenomena in which, when a metal made article kept exposed to the atmosphere, it reacts with atmospheric oxygen, water vapor, oxygen, moisture, and sometimes with acids, and get corroded. The process is called corrosion, right? So you write the definition, and after this rancidity. What is rancidity? So rancidity, when food that contains fat and oil, that means when oil and fat containing food are kept exposed to the atmosphere, it reacts with oxygen and moisture and gets sour, that means spoiled up. And by this way, the smell and the taste of the food item get changed, and the process is called rancidity. Okay. So how you write the definition of rancidity? That rancidity is the process in which when oil and fat containing food items are kept exposed to the atmosphere, it get oxidized by oxygen and resulting in a change of smell and taste. This is called rancidity. And rancidity can be prevented by using some chemical substances called antioxidant. Now, there are some chemical substances which inhibits the process of oxidation. For example, chips or anything or any kinds of food item which is actually kept in some packets where which is packed in presence of nitrogen gas, because nitrogen gas is an inert gas and which prevents oxidation, right? Nitrogen gas, N2. Nitrogen gas is a inert gas which prevents oxidation, and hence we use nitrogen gas while packing chips or anything. Chips, kurkuri, we have many types of food item, junk food item. This type of packaging is used to do in presence of nitrogen gas, because when nitrogen gas fills up these packets, it will not allow oxygen to react with the food item, and by this way we can prevent our food item from getting oxidized. Okay, so by this way we can use or antioxidant chemical substances. Now one question may arise that what is antioxidant? Antioxidant are the chemical substances which prevents oxidation. Antioxidant are the chemical substances which prevents oxidation of anything. This type of chemical substances are called antioxidant. So this is all about our today's video. In this video, let us have a summary of this video. In this video, we have discussed how to balance chemical equation and what is exothermic reaction, what is endothermic reaction, and then corrosion and rancidity. In our earlier video, that means in the first video of this chapter, we have discussed what is chemical reaction, what is chemical equation, and what are the different types of chemical reactions, etc., etc. So watch both this video. Those who have not watched the first video, go to the description, and here you will get the link of the first video, and watch the first video before watching this video. So I hope you have learned something from this video. Thanks for watching.